Good evening. I'm Jon Bek. Welcome to the CIS 117 Week 5 lecture and Hangout. I see Jason's joined us and Wendy's just logged in. Wendy, are you hooked up? Can you participate and can you hear us?
Yes, I can.
Awesome. All right. So I was just explaining to Jason that we're going to go to the mailbag for a minute here because Matthew couldn't be with us. And Matthew says, I can't figure out how to make the nulls blank in one of the current week's exercises. And that's a great question. The answer is actually just leave it. If you've got it, depending on how your database is set up, when you run the query, if you get a null result back, it'll either say the word null or it will leave it as blank. A null is as good as a blank for our purposes, but that is an intriguing question. So I thought I would show you there are a couple different ways you can actually skin that cat if you would like to do so. So here I have a little query that involves at least one of the fields from the query that Matthew was referencing. So you'll notice that, and this is not the solution query, this is just a smaller query that will, when we run it, return a null. And so what is one way that I could get rid of that null if I wanted it to actually print a blank instead of the date? Okay, so it's actually pretty simple. One way to do it, and there's several good ways to do that, but one would be to take that and use the isNull function. IsNull actually returns more than just a true or a false if something is a null. You can have it return a value. And I'm also using an explicit cast because this is a date type. And what I would really like to do is I don't want to return a 0 date type because that will give me the origin date, the original, whatever the lowest date is the system records. And that's not what I want. What I really want is to make it blank. So what I can do is I can cast the admission date field value for that particular row. I'll cast that into an InVarchar type, and I will make it into a space. So if it is null, so it evaluates the current value for this row of admission end date, and if it is null, it's going to convert it into an InVarchar of the empty space. We could also have a message here if we wanted, but we just leave it blank. And when we run that, and I'll give that new field a name test. Oh, what did I do wrong? Okay. All right, so now we have a brand new field, and you notice this calculated column, test, it replaces what was null with just a blank space. Now, the sneaky thing we could do here is we could say, well, let's rename test to admission end date and get rid of the original admission end date. And voila, nobody is the wiser. Anybody who's looking at the output wouldn't know that we've monkeyed with that field to get rid of the word null and instead have it be a space. Or let's see, can we do it this way? Can we say blank? Yeah, that works. Or this one's useful, missing. So that's one way to crack that nut. So I thought it was an interesting mailbag question, and so there you are, Matthew. I hope that's helpful. But again, if you were to just leave it alone and let it be the word null, in this case, I'll accept the word null just as well as a blank. But great questions, and hats off to you, Matthew, for really following the instructions and reading them closely, because I did kind of explain it that way, even though that wasn't my intent. So. All right, so Wendy and Jason, since you've taken the time to join us, I always like to start with the students' agenda items rather than mine. So Wendy, Jason, do you have questions, things you'd like either from week 4 or week 5, or actually any topic related to the class? I'm happy to discuss.
I do not have anything so far.
Okay. Wendy, how about you?
I guess I kind of missed the part in the book or something studying about having to qualify a field name in the select clause.
Oh, sure. So you're talking about if you're doing a join and you have an ambiguous reference. Okay. So
I understand that, you know, from the in the where clause, but I didn't realize I had to do that in the select clause too.
right. So and here's the $2 word for the day. The word is disambiguation. Disambiguation. And disambiguation means to make sure that something is not ambiguous. In other words, it can't be confused for anything else. And so when we fully qualify a name, so one way to fully qualify the name is, so for example, the patient ID that we're referencing here, we know that that's a primary key on some table, on the patient table or the person table, and it's a foreign key on other tables. So if we wanted to disambiguate it, if we were doing a join where 2 different tables have fields that have the same name, we would fully qualify it. And in this case, we would use the table. So we would say admissions.patient ID. And if we wanted to get missions.patient ID, and if we wanted to get really uptight about it, we can actually use the full nomenclature and put it in the square brackets. And within square brackets, it allows you to get away with things like using spaces and the embedded names and doing things that aren't really quite kosher, but can be useful. You know, so that would be the fully, a lot of times if you auto-generate using any of the tools, they will give you fully disambiguated names in the scripts. So if we come over to the HCIT database and let's take a look at the tables, and on the let's see, this is the admissions table. So on the admissions table, if we were to say, hey, script that table as the create statement for that table and put that in a new query editor window, if I recollect correctly, yeah. See, it uses full qualification on. Well, it's interesting. It's in the table, so probably should have chosen a different query, but because these don't need to be disambiguated, but it uses the fully qualified and square brackets name, so it's all very snooty and nose in the air about its formalism. Usually, when a human being is typing it, you know, if we do have to fully qualify it, we won't take the time to put the square brackets on. It's just extra typing for us. And one of the other things that we'll do, because imagine how many, I could have a couple hundred columns in a really complex table.
Mm-hmm.
And I would get really tired of typing admissions.this, admissions.that. So if I say from admissions A, I can not only alias a column name, I could, you know, so all right, if it's more meaningful, let's say I had 2 tables that start with A, ADM, and then I can come over here and use ADM, and then anywhere I can use that now as a moniker because it's been defined somewhere in the query. And so if I have the admissions table and I'm going to join it also with the person table, person per, then I could, you know, come up here and reference it again, per dot patient ID, which is kind of a useless thing to do, but especially if you don't spell it right, because it's going to just duplicate that field. They're keys, so they're going to be in there more than once. Put a comma and it'll like me better. All right. So we have
study chapter 2 because I had it in my head that it was just in the where clause where we had to do that. So
no, I think pretty much anywhere you're referencing it, you have to disambiguate it.
Okay.
And it's frustrating. Otherwise, it bites you. And as you found, it's kind of tedious to have to fully qualify it. all the time, and that's why a lot of times a good DBA or good database engineer is going to start adding aliases to the table names. They keep them short. A lot of times they're only one letter long, which is fine. What I don't like is if we had the admissions table and the persons table, I have seen DBAs that they'll do something silly like this. Admissions A makes sense, and then they'll say person B, and then they'll add in lab codes C. It's like, okay,
Oh, geez.
how do you make that meaningful? How about we said, if that's really what it is, how about P and how about L? Or when you get a lot of tables, how about LB and I don't
That
know,
would be pound.
PR something. Yeah. Oh, okay. Yeah. Okay. I understand that might be an objectionable abbreviation, but it's legal. Okay, so these are some really kind of more advanced things than we usually touch on in CIS 117. They're kind of style things, but they're certainly time savers and things that you're going to run into a lot in the real world because once you really know what you're doing, it saves you so many keystrokes. And here's the thing: besides saving time and effort, it makes your work more accurate. And you're like, Professor Beck, what are you talking about? That's nuts. Why would using abbreviations make your work more accurate? The more characters you have to type, the more chances you have to make an error. We see this in programming languages all the time. The error rate in VB is higher among comparably skilled programmers than it is in C++. Why? C++ is a more concise language. In other words, a lot of the keywords and operators and objects and things are referenced with a shorter moniker, and what that means is fewer keystrokes. And that by itself, it doesn't make the language any better or any worse intrinsically, but just the fact that if you're doing 800 things, 800 commands, you don't type. If the average in VB was 100 characters per line, you would have 800 times 100 characters. So as opposed to, let's say that the average line length in C++ is 75 characters for the comparable code, it'd be, right away you've reduced your error rate probably by 25%. And you may not have a very high error rate per 1,000 lines of code, but hey, 25% less is 25% less, and you got it for free. So, it does matter, and it does raise certain people's passions when they start talking about development and development languages. So there you are, for what it's worth.
Thank you.
Wendy, anything else going on?
Oh, probably, but I don't want to look like a dummy in front of
people who ask questions are not dummies, they're leaders, because everybody else is going, oh gosh, I'm so glad she asked that question, because everybody's going to have that question. So, but that's okay. So there are no stupid questions. I won't promise you I won't give you some stupid answers from time to time, and I do apologize for that. All right, so I think what I'll do now then is just move on to some parallel exercises in week 5. And let's see, did I remember?
Yeah, because answering the ambiguous thing for me will help me with number 4, because I got that on the primary diagnoses, so that should help with that. So yeah, the parallels will help me, I think.
Okay, good. And I started a few parallel exercises in last week's lecture, and I think we may have gotten sidetracked or run out of time before hitting all of them. One of the things I want to remind everybody about is this is not your only opportunity. So through the week, if you post to the Q&A discussion about, or you say, would you please give me a parallel example of solving this problem? I will either give you text, or I can make a little mini video. It's very easy. It doesn't take any more time. Sometimes it's less time to actually show you than to try and write up the document to describe it. And so I will link additional questions to help you. And in some cases, if I look at it, like there's one this last week that's rough. It has to do with the self-join. And self-joins, if you've never done them before, are just kind of weird to wrap your head around. I'll be happy to post a parallel example if I didn't already address it. Or even if I did and you just need to see a different take on a parallel example, I am more than happy to do that. And let's see here. Oh yeah. Okay. So here is my Chapter 6 worksheet for our parallel work. Let's see if I can make this stack up. I can, and even maybe get it on the same screen. There we go. Okay, so what I have done is I use different data sets for this class, this term, and I always ask you your questions, your homework and exercise stuff almost always comes not out of the book example because the textbook examples, the solution sets tend to get out there and it tends to distract from actually learning the material if people start leaning on the solution sets. So what I do is I have an e-commerce data set I use some terms, and I've just created a healthcare information technology data set that we're using this term. And I parallel the questions that appear in the book in the back for the exercises. And so I'll be happy to tell you which ones parallel what, and then I'll solve the textbook example and give you, you know, the solution there. So if we take a look at the first question we have in the week 5 work, chapter 6. So it's saying, insert into the metabolic panel table the lab code ID, lab name, lab units, and lab charge from lab codes table from each lab code, that, or it should say, not that, just whose name begins with the string metabolic. Okay, so we're creating a new table, and so we need a create table statement. This is really similar to what we're going to do with the TAL exercise from the TAL database. Insert into the non-game table the item number, description, number of units on hand. Okay, and so the first thing we need is to do the preliminaries, which is to create that table. We can't do that until we've created the table. And so in most cases, we're recreating existing fields. If it needs new fields, if I don't give you any guidance, you can use your best judgment on how the field should be defined. But one way that you can look very easily if you're using SQL Server Management Studio and see how any of those fields are defined if you've got to create a new table is, you know, pick the table where you think you would be creating that from, go in and look at the columns, and if you open up your Object Explorer a little bit larger, it'll show you that admission ID is an integer and it has a null, not null restriction on it, and patient ID is an integer, but a null is allowed. I don't know if it should be, but it is. Admission start date is a date time. And so the different data types on all of the columns are listed right there. So if you need to copy a column, you can figure out how to create it. You could, if you were using the table designer in SQL Server Management Studio, you can build the tables by hand, but that's not what we're asking you to do. We're asking you to actually run the queries that would create the tables, create a query that, and we call that, you know, up until now we've been using data management language, the kind of SQL we've been using, DML. This gets us into something called data definition language. Okay, so I guess before we get started, I ought to go look at TAL and see, do I already have the table non-game created? And we don't. Okay, so then what we need to do is craft the create query. And a really handy way, if you are having trouble learning the query language to do this and you want a shortcut, is you can always come over and grab a table. So let's see, non-game is going to have description, on hand, category, price. So this is a lot like I think probably the orders table. Let's see. So our columns here are now order line. Let's see what the columns are. Order item num. Okay, so this would be similar to this table here, and I can come over here and script table as create to a new query editor window, and there it is. So there's the create table statement all built out for me. So I could take that and just start modifying it in order to get this equivalent query. And let's go ahead and run it and see if I've got that right. Okay, so that's created. And the disobliging thing you will recall about SQL Server Management Studio is it doesn't, the nice thing is it doesn't waste a lot of bandwidth refreshing until you tell it to, because every refresh costs a lot of transactions back and forth to the database. The problem is if you then go look at the tables in TAL, you said it just said this created non-game. Do you see non-game? I don't see non-game.
Mm-mm.
Remember that it's been done, but you have to refresh your view. So if you come over here, refresh it, and now we should see, oh my goodness, you know what I did? I'm glad I made this mistake because it's classic. Let's come over to HCIT. What was the last
You didn't
example
specify the TAL database.
I didn't specify the database, and so what island was I standing on?
HCIT.
So, and I've now polluted my table space. Oh gosh, that is a terrible thing to do. So let's make sure I've refreshed. And is that where I built it? So if I looked under the tables,
Yeah.
oh, yep, that's where it is. Okay, that's good. That's good. I'm glad. So Wendy, you were worried about stupid questions. There's one of my stupid answers. I showed you a wrong way to do it, but hopefully that'll be a problem that somebody else will run into. I'm just going to go ahead and drop that table out of there. So what I need to remember to do then is let's be explicit, use TAL, and let's run it. And now we look at the tables over in TAL. And
It's too bad the messages didn't say where it dropped it.
it's not really helpful, is it?
Yeah.
Make that's a great suggestion for Microsoft. Dropped it from where? Okay, and again, I'm missing it here, so let's come in and refresh. And did I get it in the right place? Oh no, I'm in HCIT, John. Look and tell. Non-game. There it is. Yay. So if I were to go out and query out the top 1,000 rows, as we expect at this point, it's empty. So everything else we're going to do is going to be working on that. So let's clean things up. And let's get a new query going. And let's be explicit. Use TAL. So I am now using TAL. Thank you very much. All right. So now what I need to do is I need to populate that table, and I'm going to steal the lab code ID, lab name, lab units, and lab charge from lab codes. Okay. And so that query looks a lot like a select query. As a matter of fact, I could have started building it, and I probably would be well advised to start by building it rather than as insert into non-game and then all this. Start out so you can eyeball what you are trying to do as just do the select. So that's harmless, right? Because the select doesn't change anything. Do that and go, does that look like what I'm supposed to have? Yes, it does look like what I'm supposed to have. Great. If that's the case, now we'll run this, and we're going to run it exactly one time. We want to run it no more than one time. If you run it a second time, one of a couple things is going to happen. One is if we're providing the primary key, we're going to get a bunch of errors because the primary key can't be duplicated. If we're using an auto incrementer, as is often the case in the real world, on the primary key, so we're not actually explicitly adding the primary key, it's been synthetically generated for us, we will duplicate rows. The only thing unique about them will be the primary key, and then we have a real mess on our hands. So having run this once, we don't want to run it a second time. We want to be a little bit careful about doing that and mindful, because that's an easy mistake to make.
No, I could see myself doing that, yeah.
Yeah, so I'll tell you what I'm going to do is I'm going to use a bulk comment. So you've seen the individual comment, which is the double dash. That does one line. You can also do a block comment like that. That way I can't accidentally run this. And now here's our sanity check on the work we just did to see that it really did come the way we want it. And now if we execute it, there it is, and that looks good. Yay. Okay, so your problem, which has to do with creating a metabolic panel table, for your labs. You're gonna do a subtable for some work extracts, transforms, loads that you would often do in industry. ETL, there's even a name for it, extract, transform, and load. You build temporary tables. You do things to build data warehouses for common queries and basically to pull stuff out of your main database, so that it's, if your transactional database, it's not getting hit as hard for query support as your actual live database that has to actually check patients in and out of the hospital. We can go to a data warehouse or data store to get those answers. And we can talk about that extensively in one of the later CIS program offerings if you take one of the data warehousing classes. All right, so that's number one. Let's take a look at number two. Number two says, okay, so in this metabolic panel table you just created, change the lab name of lab code 5240 to metabolic CO2. Okay, so our parallel to that is TAL number 3, which says, hey, in the non-game table you just created, change the description of item number DL51 to classic train set. So in both of these, we're working on that table, we're finding a particular row, and we're changing the value of a field in that row. Very analogous. Okay, so the way that we would do that then is, now we're doing, instead of an insert, we're doing an update. We're going to update non-game, set description, classic train set, where item number equals DL51. So a good thing to start with would be to say, well, let's just make sure that it's in there. So how about we say select star from non-game where item num equals DL51. And let's just run that one piece first and see. And what have I missed? Didn't close the quote, just like it's telling me. Okay, so I see that it's there. So now if I run this, and right now it says that it is a classic railway set, and I execute this, and now if I go back and select it again, I see that it's changed to classic train set. So that worked properly. Yay. Okay. So exercise 2 knocked out. Exercise 3, in this table that we've built, metabolic panel table, increase the lab charge of each lab code whose lab units are measured in microliters by 7%. So hint percent multiplied by lab charge by 1.07. Okay, so it's 107% is a 7% increase of what it used to be. Okay, this is very similar to exercise 4. In the non-game table, increase the price of each item category by 2%. Hint multiplied by 1.02. So really the same exercise, just on a different table. And what we're doing here is we're doing an update, but we're doing it not on an individual record. We're doing it on all qualifying records, and we didn't filter it by anything. So it's going to do all of it. Okay. So we're going to update non-game, set price equals price times 1.02, or category equals toy. And again, if we wanted to see this ahead of time, we could say select star from non-game where category equals toy. And we could just run that, and we'll be able to see what that's going to be. So this logic, by doing that, we're making sure that we are actually selecting the records that we want to operate on. right? Because it's really easy to miss something, and this is kind of a great habit to sanity check stuff before you pull the trigger on a change. Is do a select first, do it before you do a delete, do it before you do an update, do it before you do an insert to see, you know, if you go to insert something, make sure it's not already there. Is a good sanity check. Just good habits and useful. We could even, if you wanted to expand this, we could select item num description on hand category price as old price times 1.02 as new price. See what we're doing here? So this is a way we could look at the whole thing before we pull the trigger and say, is this really what we want to do? And description, got to spell it right, Beck. Oh, don't hit. I got lots of queries on that screen. Highlight only the one you want to fire. There you go. So we can see this is what it ought to be changing it to. And so if we now pull the trigger on that, we're happy that it's really doing what we want it to do. And there they are. And yep, that's what we wanted. So great. Good sanity check. Good good result. All right. Our next exercise, add the following item to the metabolic panel. So we're doing an insert: lab code ID 5310, lab name metabolic alt, lab units microliters, and lab charge is 31.05. This is very similar to TAL number 5 that says add the following item to the non-game table: item number TL92, description dump truck, number of units on hand 10, category toy, and price $59.95. And there's the query that does that. So let's study that. Okay. And again, not a lot to sanity check here other than if we run the select query ahead of time, because there's two ways to do, well, probably more, but there are two general ways to do an insert. One is you name each field, and that way it doesn't matter if some DBA has come along and inserted an extra field in here, and your query is it's only going to insert 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So what would happen if a DBA had come unbeknownst to you since the last time you wrote this query and modified the table to add additional, let's say the item number is also going to have a manufacturer's item number. All right, for some reason we add a category. It would mean that these inserts would fail because we would be missing one element. So the other way to do that is we could create it so that we name each field that we are inserting into. Okay, this is a shorthand way. It's much less typing. The other thing we can do here to do a sanity check is select from non-game where, and let's see, item num equals TL92. Is there one already existing? There is not, and that's what we wanted to see because we're going to insert this one now. So let's go ahead and do the insert. One row affected, so it didn't fail. And now if we check, sanity check says it is. It now does exist. All right, good, good. Let's take a look at number 5. 5 says, delete every record in the metabolic table for which the lab units is, I don't know what MMOL per liter, micromoles, millimoles per liter, perhaps. I don't know. I need to talk to a real medical person because I got a lot of my sample data from a data generator. And so some unit of moles per per liter is what we're measuring. That parallels tile number 6. Delete every item in the non-game table for which the category is puzzle. So this is similar to what we did before. We did an update for many different records. Now we want to do a delete for many different records. And this one you really want to sanity check these kind of things before you pull the trigger on them, because once they're gone, they're gone. We can set checkpoints and then only commit the transaction after we're sure. But the point is, whether you are using transactions or whether you're just operating with direct queries that commit after every query, we want to make sure that we're very careful when pulling the trigger on deletes. So let's take a look at that. Excuse me. So before we delete, let's select star from non-game where category equals puzzle. And this is going to tell us two things. Number one, is there anything for us to delete? And we can also eyeball the data and say, did you really want to delete that? Okay, so I got 1, 2, 3, 4 records that are going to be deleted. And yeah, I guess we're getting rid of puzzles. So let's go ahead and fire them off. Bam, 4 rows affected, exactly what we expected. And run it again, and there are none that match that. Wait, did we kill our whole table? Let's double check. So let's just get rid of the where category and run that. Nope, still lots of data left. We just killed the puzzles, so that's what we were supposed to do. Joy. All right, so we've killed our puzzles. In the metabolic panel table, change the lab charge for lab code ID 5160 to null. And that's interesting. In thinking about that, we want to make sure that that isn't a primary key. Can't be if we're going to set it to null. That would fail. The other thing we ought to think about that is that a foreign key? And if it is, and it most definitely is, would that in the table that it came from, is that by intent? Are we intentionally decoupling that row? Are we going to leave a widow and an orphan behind, or are we going to finish relinking that? It's linked to the wrong key, and we want in another table, and we want to put a new value in there so we can relink it. Things to think about. Okay, this parallels 7 in TAL. I think that's our last exercise on the TAL data set tonight. In the non-game table, change the category for item FD11 to null. And so that would look like this. Okay, so before the update, let's just do a select star from non-game where item num equals FD11. Do I have one? Yep, I have one. And so we're going to change that category, which is currently toy, to null. We've decided rocking horses aren't toys. We don't know what they are, but they're definitely not toys. So let's go ahead and run that update. 1 row affected, that's fine. And then run that again, and there it is. We see that that now is equal to null. Great. On to the colonial data set. And I think we have a preliminary there. So, yeah, just as we started by creating an additional table, a sort of a temporary table to work with, we're going to do the same thing here to get set up for colonial number 2. We're going to build this table. And so the same thing applies. We could start by looking at the table that it's going to be similar to and build the script, the create. But the most important thing we want to do here now is use colonial so that we're working on the right table, not put it back in HCIT. Let's not repeat your mistakes, Beck. And so we're going to create a paddling table to work on. And first, let's do this. Does it already exist? And remember, you can always wipe these all out and use the scripts to recreate them. Okay, and so in the tables, I do not see a paddling table. So let's go ahead and fire away. It says it completed successfully. I don't believe it. So let's double check, refresh before we can see it. And there's our paddling table. And if we select the top 1,000, there's nothing in it. So it's a brand new empty table ready to go. Happiness. All right. So now that we've got the preliminaries out of the way, the table's created, we want to insert into the paddling table trip ID, trip name, state distance, and all those other good things. And we're getting them from the trip table, but only those that are type paddling. Okay. So we're building a subset table, a small table that probably for use as a temporary table to do some data manipulation or analysis on. It's probably going to be a throwaway, but we're getting it out of the main table. Makes a much smaller data set. Also, make sure makes it easier for us to mess with it without putting our production data at risk. So, not that we'd be doing even this without some sort of backup to what we're about to do, but yeah, this is all good and very real world practice. Okay, so there's our insert statement, and by now you can almost sing the song with me. Before you go doing anything that changes data, let's see what it would do by running a select statement first. So let's get rid of the insert, we'll keep the select and see what it gives us. Okay, so over on the source table, it's going to give us these 9 rows. Are they really all paddling? Yeah, I guess they really are all paddling, although interesting, we didn't put paddling in the type. So because this table only holds paddling, we didn't put the type in here. Let's put it in there just for a moment to see it. Oh. Yeah, and so that is successfully giving us a filter of only the paddling types. Take that out and restore the insert and let it run. And it's also run that for us. And so we see the data is indeed in the paddling table now. I am ecstatic. All right. So number 8 says, in our assignment, it's for all married patients in the Icelandic patient table, decrease the patient population percentage below poverty by 0.02. This is very similar to colonial number 3. For all trips located in Connecticut, increase the maximum group size by 2. Update the paddling table accordingly. Okay. So what that's going to look like is this. Update paddling, set max group size equals map group size plus 2, where state equals Connecticut, and take a moment to think about the math. Is that what it told us to do? Because it's funny, when I grade in my rubrics, if you forget something like an order by statement, you probably only lose a half point. If you do something really simple, like blowing up some simple math, I probably take the whole point from you. And the reason for that is that if the report is out of order, somebody's going to notice and ask you to rerun it. It's not a fatal kind of thing in business, or they could even just deal with it. If they import it to a spreadsheet for further work, they can sort it in there. If you get the math wrong, you just misinformed business, you're going to lose your job over that if it's a major loss. You got to get the math right. And so I kind of have a similar kind of penalty. If you don't get it right, the whole point is lost. So yeah, I'm kind of nasty about that, and I apologize, but I'm not going to change my ways because I think it's important. Burnt hand teaches best on this one. All right, so we're going to update paddling, set group size. We could even check that by making this into a select and make this as we did before, a calculated field to see the before and the after field. I think you got that with the first example. If not, go back in the recording and rewind, and let's give that a shot. So look at it before, there it is, and we're gonna change the group size. So this first one, Bloomfield Maidstone, max group size is 6. Now we fire off the entire mess. Max group size is 8. That sanity check looks pretty good. All right, onward. Number 9, insert a new patient into the Icelandic patient table. The patient ID is 999999. The gender is male, if I could spell. The date of birth is January 1, 2015. The race is white. The marital status is single. And the patient population percentage below poverty is 1.23. This parallels colonial number 4, which says insert a new trip into the paddling table. The trip ID is 43. The trip name is Lake Champlain Tour. The state is Vermont. The maximum group size is 12. The distance is 16. And the season is summer. Okay. And this is one that I see blown a lot. And what people may have problems with is getting the columns 12 and 16 in the right order. So it helps to do a select ahead of time. Okay, so this is going to go in because we're not naming each field, we're just using the ordinal number of the field for the placement. So ordinal meaning the order it's in. So this, before the first comma, will go into column 1. This will go into column 2. This will go into column 3. This will go into column 4. So 1, 2, 3, 4. Distance is 12, max group size is 16. Go sanity check what it told you. And it says max group size is 12, distance is 16. And is that going to put us, so is this forward or backwards from what we want it to be? I've lost everybody.
It'd be backwards.
It is backwards, okay. And so depending on how the table is ordered, because we can create these tables with the fields in any order, we can even move them around. It doesn't really matter. But if you're going to use the ordinals, you got to get that right. So we want it that way. And then let's change our select. I thought it suddenly gone Scandinavian there. Where trip ID equals 43. And let's run that. And let's check it. Is that right? It says distance is 16, back to our specification, and it says distance is 16. Good catch. Right. So this is the problem with using ordinals rather than specifying the field name for everything on the insert. And of course, just looking at those as a column, when you're usually doing these, there are dozens or hundreds or even thousands of rows that you're updating or inserting. It's really hard to catch something like that. You need really good eyes, but better yet is to maybe double check a couple of the inserts before you do the whole batch and make sure that because usually you're extracting from one system. Maybe we have a transaction processing system that is from our ticketing system selling the tickets for these tours, and we're putting it into our decision support database or data warehouse so that our business executives can do some analysis on it and see, do we need to develop new tours, or are there tours we need to put more guides on, or do we need to reduce because there's less demand for them this season? All those kind of decision support kind of things is one of the reasons we would be extracting from one system and putting it into another. And you get something like that wrong and it skews the whole batch. You can make some terribly bad business decisions before you finally figure out that your data was messed up, and by then the loss can already be materialized. You can actually have less dollars in your banking account, and that's not a good thing.
Quick question.
Yeah.
When inserting numbers, we can insert it technically as a string and it converts it to a number if it's a decimal or integer column data type, correct?
Microsoft SQL Server is extraordinarily forgiving of bad habits. Yes, you can in Microsoft SQL Server. You will find that if you try that in Oracle or MySQL and other databases, it will complain at you, and you'll learn better habits in a hurry.
Okay.
The other thing to consider, and that's a great question, that's a very insightful question, if it has to convert, let's say I'd done it this way. Okay. In order to make that data fit, it has to make sure that it can convert it. If I were to put something weird in there like 16x, that can't be converted to a number. That insert, will fail if it's going into a numeric data type. When it tries to convert it to a number, it's going to fail, and so you're going to get an exception on that row. If you do it this way, it will succeed. However, you just chewed up a small number of additional CPU cycles in order to do a string conversion operation that wouldn't have had to be done if you did it this way. So all things being equal, if you can use the correct data type, that will save you that one bunch of CPU cycles on that one row. The thing we have to watch out for is if we're, sometimes, like if we use a string expression, when a number expression is called for, it has to convert it once in the query. Other times, when we're doing a query that affects, millions of rows, especially if it's on joined tables, if it has to convert it in each of those rows, now you're multiplying by millions each of those extra few CPU cycles, and suddenly your performance can really fall off. So learning to watch those things is really the mark of a pro, and it makes for more efficient code. The other thing you'll find out about is if you take additional, more advanced courses, and particularly in things like database design and in database administration, there are tools we can run on the queries that we run the most, or the queries that are really the biggest, and those are the ones that are going to hit us the hardest if they're inefficient. And we can run something called describe plan, and describe plan will show us the plan of what all the steps are that query has to take in order to fulfill what you're asking it to do. And so it will show you if it's inefficient because it can't find indexes that if we had built those indexes on the table, it would make that query faster. It will show you things, inefficiencies in your code or your approach, and can help you if you take the time to look at them to write better code. And so it's really a question of diminishing returns. Would we run describe plan on every query? No. But if your query is going to impact a lot of data, or if it's a query that's going to run every day, millions of times, every user who comes to your online e-commerce website and looks up something in your catalog, it causes that query to run, you really want to tune that one, because that one, you hope you get tens of thousands of users an hour, let alone in a day. And so if that query is firing off that often, even a small performance increase can make your website snappier. And we all know that the faster the website is, the more likely that the customer is going to stick around long enough to complete the transaction. So it literally is more money in your pocket. It also means that you, with the same hardware, if you're using the hardware you have more efficiently, that means that you forestall when you have to spend more money on bigger hardware. And so these are all really, really important considerations. And, if you want to get out there and make, $80,000, $90,000 as a DBA, you don't have to be all that good. If you want to be making six figures and better, or you want to be the DBA that's managing the department, or you want to be the data architect that is overseeing the design of the databases for the whole division or for the whole company, or if you want at some point in your career, you want to be the chief information officer, paying attention to these kind of details and developing, some real chops when it comes to watching out for performance and minding the store really pays off. So I've never been that good. That's why I teach. But I know what good looks like, and I hope to point you in that direction. So, great question. All right. You bet. All right. So next thing is we're going to pull the trigger and kill a whole bunch of records. Delete the patient in the Icelandic patient table with the patient ID 10,000. So not a whole bunch of records. That should be only one because that's a key. So it should only be able to delete one row. And so we probably ought to check that. The parallel is delete the trip in the paddling table with the trip ID 23. And so always, and again, best practice is, let's check it. Select star from paddling, where trip ID equals 23, and it's there. Okay, so if I change that select to a delete, then it should only kill that one thing. And let's see. Should never try and do stuff without, you haven't practiced in a long time without your notes. All right, so I haven't shown you this. We'll do a little foreshadowing here. This begins a transaction. A transaction marks all the changes you make, even if there's hundreds of changes in them, as atomic, meaning that until you tell it to commit those transactions, nothing has really changed. So if we do this, bam, command's completed successfully, and I try and select it, and still there because it got rolled back. One row affected. Now run this one. It's gone. Now. Completed successfully. Select it. It's back. What the heck was that? By putting this marker, I said begin a transaction. And usually on something this small, you wouldn't create a transaction. But I could be doing a whole bunch of things. I need to delete this, but if that, only if I delete that successfully, then I want to add this other thing. And if that adds successfully, I want to do this other thing. And then, you got 5 more things. But if any one of them fails, I want to be able to roll it back. That's like your undo button. So this, actually, would probably go ahead and indent everything between the beginning and the end. The other alternative is if I was happy with it, I could commit it. And if I commit it, now, even if I try and roll back, I got nothing to roll back because it was already committed. I didn't make a new transaction before trying to roll it back again. So kind of nifty stuff. We'll be learning about that toward the end of the term, but I thought it was kind of fun to play with. If you want to explore that, since these tables are really small and you've got the scripts to rebuild them, after you get your work done, go nuts with it. So that's the other thing that we would do if we were going to delete a large part of the database. We might play with that first. The other thing we could do, anything let's say we're going to delete 100,000 rows on a table. How about we select them first and put them in a temporary table, and that way we've got them cached until we're sure that we have the exact result that we wanted before we really delete the temporary table. So we put them into another table first, select into, and then drop them out. And then after the end of our shift or the next day, things are looking good, we can drop that temporary table. So we always leave ourselves with a backup plan. All right, good stuff. And 8:31, we're a minute over time, but we only have one more to do, so let's go ahead and finish off the set. So our exercise or our assignment says the patient whose patient ID is 10017 is now married. Update the record to reflect this. This parallels Colonial 6. The distance for the Pontoon Reservoir Tour trip has been increased to an unknown number, number. Change the paddling table to reflect this change. What is unknown? Oh, null. We use null for unknown. So we can explicitly change something to a null. You got to be careful with this one, though, because there's a very simple mistake that is commonly made. And let's go ahead and make that mistake. Is that going to work?
Nope.
And the reason that's not going to work is I'm trying to store the string NULL in distance. Distance, if we go look on the paddling table in the column, it is a decimal. It cannot store a string. The insidious thing is if that happened to be a varchar definition on that field, then it would allow us to do that. But the word null is not the same as the value null. And that one can really get you messed up. So let's try this and see what happens. Bam, invalid column name null. Okay. Oh, and I probably should have used single quotes, right? Let's try it with single quotes and see that it still doesn't work. We'll generate a better error code. Error converting data type varchar into numeric. But again, if that had been a varchar where a number or a string could be stored, that would be bad. It would accept it. So now let's go ahead and execute it. And now if we go find select star from paddling, where trip, actually I'm just going to copy this. I don't have to type it. And now if we look at it, there it is, and the distance is null. All right, that's all I got. So thanks for coming and sharing in our Hangout. Any questions come up while we were looking at the parallel exercises?
I think I'm good.
Great.
Okay.
You good, Wendy?
You'll be getting questions from me during the week.
I look forward to it. You know, one of the reasons I do these Hangouts for you guys, and I know that very few people have the time. That's why they're taking an online class. They can't always attend live, but I want you to know that there is a real live instructor on the other side. I really do care about your success. I like your questions, and I'm happy to answer your questions. There are no stupid questions, and it's okay to ask me the same question 3 or 4 or 5 times. It's my job to find 3 or 4 or 5 different approaches to answering it until we find one that makes it click for you. And I love my job, and
That's really helpful. Yeah.
And I want to see you guys succeed. So because that's really what it's about. We already know that I've failed in life because that's why I'm teaching, right? Because those who can't do teach. Actually,
Yeah.
I've had a pretty good career, and I'm pretty fortunate to be here and love teaching you guys. So keep the questions coming.
Thank you.
All right.
Good night, everybody.
Good night, everyone. I'm going to go ahead and end the meeting now.
All right. Good night.
See you next time.